Should I start? I'll just be a couple of minutes.
Yeah. No, thank you so much.
Okay, let's get started. Good afternoon. Good afternoon, everyone, and welcome to this very special workshop on governance at the technological frontier, how to translate research into policy for AI oversight, clearly hugely important topic today. My name is Venkat Guruswamy. I'm the director of the Simons Institute for the Theory of Computing. A few words about the Simons Institute. It was established in 2012 with a very generous gift from the Simons Foundation. And our mission is to bring together the world's leading researchers as well as outstanding young scholars in theoretical computer science. And the goal is to explore deep unsolved problems about the nature of computation, but also expand the horizons of the field by exploring other sciences and interaction of technology and society and other aspects through algorithmic and computational lens. So, and this workshop is part of Simons Institute's Algorithms, Society, and Law initiative, which was established to address the broader societal implications of the technologies addressed within our research programs. So we are delighted to be partnering with the CITRIS Tech Policy Initiative in organizing today's very special event. And we invite you to, for greater outreach, we invite you to live post this workshop on social media. And if you do so, use the hashtag SimonsLive and tag us at Simons Institute so that anyone outside can also follow this very interesting and topical event. We would really like to acknowledge the generous support of the Simons Foundation and Simons Foundation International, as well as our many industry partners and individual donors. Your support makes our research and events like this possible. And with this, I'll now invite Camille Crittenden, Executive Director of CITRIS and the Banatov Institute and co-founder of the CITRIS Tech Policy Initiative, to say a few words.
Thank you. Thank you and welcome everyone. I'm delighted to be here and so happy that CITRIS could co-sponsor this event with the Simons Institute. I think this is the first such collaboration that we've had, but I hope that it's the first of many. CITRIS is a Center for IT Research in the Interest of Society. That's the acronym. We occupy a building over on the north side of campus, Utarjadai Hall, if you're ever on that side. Our name really says it all. We try to help faculty members to bring forward emerging technology that's going to have a positive social benefit. Some of the research initiatives, in addition to the Tech Policy Initiative that we help to support, are in aviation, in climate, and in health. We also have a number of other programs, workforce development programs and some entrepreneurship programs, but really we're here today because of the Tech Policy Initiative, and I really want to salute the organizers and say thank you for all your hard work, Stephen and Ruji and Greg, for doing the work to bring us all together today. It's going to be a fabulous afternoon, so thank you for being here.
Thank you, Camille. Hello, everyone. Welcome. My name is Greg DeMerchant. I am a Law and Society Fellow here at Simons and also one of the organizers, along with Ruji and Stephen, who've been just such exceptional partners in this. So I'm very happy that I had their assistance. I have the distinct pleasure of introducing our first speaker, who is a rock star, Inioluwa Deborah Raji. Deborah Raji is completing her PhD in computer science at Berkeley, is currently an academic fellow at the Leadership Conference on Civil and Human Rights, and was formerly a senior trustworthy AI fellow at the Mozilla Foundation. She's worked closely with industry, civil society, and within academia to push forward various projects to operationalize ethical considerations in machine learning practice and push forward toward benchmarking and model evaluation norms in the field. She's been named to Forbes 30 Under 30, MIT Tech Review 35 Under 35, Innovators, and the Time 100 Most Influential in AI. She's also the recipient of the 2024 Tech for Humanity Prize and the 2024 Mozilla Rise 25 Award, as well as the co-recipient of the EFF Pioneer Barlow Award with Joy Bialamwini and Timrid Jibru. Please welcome our first speaker.
All right, hello? Okay, perfect. Thank you. Okay, so hi, I'm Deb, and I was told I could talk about anything I wanted. So I was going to talk about, and Suresh was literally just making fun of me a couple minutes ago about what I'm choosing to talk about. But effectively, I'm here to talk about the fact that for those of us that have kind of been in this AI policy space for a while, my work is very focused on like AI product accountability, product safety perspectives. It's been about like 10 years since the conversation has gotten started. And so I noticed that there's a lot more computer scientists, there's a lot more computer science researchers that are sort of curious about what's going on in AI policy. And I want to share a little bit about what's happened in those last 2 years and my reflections on it and of what we might need to do moving forward. And so that is what my talk is about, is effectively this sort of like retrospective of 10 years. Everyone in the room was probably born 10 years ago. I hope you were all conscious 10 years ago, but you might not have been paying attention to this. And so hopefully someone will learn something. And Suresh was definitely there for all of this. So you can fact check whatever I say. Yeah, he was like definitely like in the rooms and named in many of these reports at that time. So if you want like a really senior perspective on this, yeah, definitely bug him afterwards. But the story that I want to tell starts with in May 2016, the Obama administration, towards their tail end, Obama, yes, I said the word, he and his Office of Science Technology Policy, which at the time was really championed by someone with a great computer science background, Ed Felton, and various other civil society folks, they wrote this report, which is kind of canonically known as like the big data report, but it was a report about AI effectively and sort of AI safety, fairness, and some of these topics that we now discuss today, but in 2016. And so this report kind of launched a lot of the academic conversation. It inspired a lot of civil society focus on these topics. But most importantly for this conversation, it was sort of the first kind of, at least that, I am also young, and Suresh will definitely fact check me later, but this was sort of the first big policy moment coming from the Obama White House around AI as like a sort of, as we understand it today, and AI-related policy topics as we understand it today. Oops. This is not working as well as I thought. Okay, literally later that year, it inspired one of the first congressional hearings on AI. So there's a congressional hearing that happened November 2016 on a committee in which Ted Cruz was the chair, which is like, feels like whiplash right now because he has shifted his position a lot. In his opening statement, he mentions AI fairness, which is definitely whiplash for some of us that are following the situation now. But yeah, he chaired this committee on science and technology, and they had the first sort of congressional hearing that I'm aware of that mentions AI. This happened November 2016, almost pretty much in direct response to this report. And Greg Brockman from OpenAI was there, which was pretty crazy because OpenAI was founded in 2015. So just a year after OpenAI was founded, they were part of this sort of first congressional hearing on AI. So they've always been really part of that conversation of what AI is from the beginning. And then a couple years after that, we're in the Trump administration now. They actually were the first to have an executive order on AI. And they also, I think a lot of people miss this, they were also the first to kind of really push on any kind of meaningful legislative action on AI. So the National AI Initiative Act of 2020 was snuck into like an appropriations bill during the Trump administration, and it kind of led to a lot of things like, I don't know if anyone remembers this logo for the National AI sort of initiative office. It led to like NIAC, which is sort of the National AI Advisory Council, the role of NIST, the National Institute of Standards and Technology, and a lot of AI standards development came out of this. But this is sort of like 2019, 2020. And so, we've had this conversation of AI in the US sort of starting in 2016 onwards and focusing on a variety of different topics. And so one of the things that I've always really wondered has been, well, it's actually been about 10 years since 2016. So, what have we actually been effective at accomplishing in AI policy in those 10 years? There's certain topics that we were talking about in that 2016 report that we're still talking about in 2026. How much of that, if any, have we made progress on? And then I think my own personal curiosity as someone that sort of is affiliated with a computer science department, for better or for worse, what does that have to what does computer science research have to do with this? How has computer science research shaped this outcome, if at all? And so, and so that's sort of where I'm kind of coming in. Obviously, a lot of this retrospective will be incredibly biased. I sort of see myself as operating at the intersection of computer science and public policy to think about specifically AI accountability in complex real-world situations. So I think about sort of, audits and accountability for deployed AI products. I take more of a product safety lens, and I work a lot with different practitioner networks. So these are different groups that are trying to deploy AI systems, different civil society groups. Someone mentioned the Leadership Conference, but ACLU and CDT are groups that I've worked with for a long time, Suresh also. And then I've started working more recently in the last year and a half with these government research organizations called AI Safety Institutes, and I'll explain later what they are. But I've been working with the AI Safety Institutes in Canada, the UK, and the US. And then within the US, I've worked with a couple of interesting stakeholders in this. So one is the Federal Trade Commission. The other is NIST, like I mentioned, the sort of standards research organization for technology in the US. And then the last one is ONC, which is like an IT healthcare regulator. And so, before I get into my thoughts on, progress that we've made or not made in the AI space in the last 10 years, and what role computer science research did or did not have to play in it, I do want to address the sort of elephant in the room, which is, that scope disclaimer that 10 years ago, what we were talking about when we were saying the word artificial intelligence is not necessarily what we are talking about today. And the best kind of illustration for this that I can bring up is an example from a class me and Avi taught last semester on predictions AI and public policy, where we pretty much gave the example of a May 2023 hearing that happened. There were two hearings that happened in the Senate building, the same building. One hearing happened in room 562. It was on artificial intelligence in government. This is my friend Dan Ho at Stanford Law School. He's testifying there. The second room, this is, by the way, these both happened the same day. The second room is room 222. And this is, our favorite guy, Sam Altman, and he's testifying on rules for artificial intelligence. This is with the Committee on the Judiciary. They're talking about completely different things. In Dan's room, 562, they're talking about things like facial recognition. They're talking about risk assessments, because it's very focused on government use of AI. So these are practical tools that are already being deployed today. Meanwhile, in Sam Altman's room, they're talking about ChatGPT. And it's interesting because both of these are incredibly impactful. ChatGPT, this is a picture from the California Nurses Association. It's affected, people are striking, people have thoughts about products like ChatGPT. But the reality is that actually a lot of what we think about as AI, and historically about 10 years ago, what we were talking about were these risk assessments, were these facial recognition tools. And so, and that is also still incredibly impactful and widely deployed within government. So this is Tammy Dobbs, who's had health benefits reduced drastically due to the use of a risk assessment. And the reason I talk about room 562 and 226 is to understand that both of these are relevant. We're talking about the entire spectrum of what is put under that marketing umbrella of AI. When I'm doing this retrospective, I'm sort of curious about how computer science research has been relevant to any and all of these things. But very important to understand that these are two very different distinctions. Something I like to point out that Dan doesn't like is that you can see which room is a little bit more popular than the other based on these photos. Clearly these days, there's quite a few people interested in room 226, but that doesn't make room 562 any less relevant. So again, back to this question, given our sort of broad definition of AI, what has been most effective, or what's my opinion, what's my take on what's been most effective, especially sort of points of impact from the computer science world. Obviously, I will selfishly focus on things that I feel I've been able to contribute to. So one is sort of this idea of practical coordination. The second is this idea of building technical infrastructure for AI accountability. And the last is this kind of maybe broader, more foreign idea to a lot of computer scientists, but this idea that I've learned a lot from my legal collaborators is this idea of institutional design and investment. So let's start with what do I mean by practical coordination? So, at the beginning of this AI policy journey, this is like 2016 and 2019, all the way to 2020, there was this, folks that were there probably remember the like trauma of like every other week there was a new AI strategy, AI principles statement, AI principles report coming out. It was a very big trend internationally. Of course, the US participated in it, but you would have countries like Nigeria and Canada as well. There were over, 1,000 of these sort of like AI policy, initiatives coming out, but everything was very vague for many years. So this is a period of like 4 to 5 years where no one really did anything, but everyone really loved to put out a report and a strategy. At some point, post-2020, we started seeing a little bit more concreteness, like legislative bills. These are really small. I realize that on the stage right now, but effectively we had, the AI Accountability Act for anyone that is in the US or has been working at the federal sort of AI policy stage. That's probably like the AI Accountability Act of 2019 is what I'm talking about, not the one that was reintroduced in 2022, but both of those were sort of like making AI policy relevant statements through legislative bills. I think that was a really big trend. And then we were seeing a lot of things happening in the EU. So like, the EU AI Act was being drafted and debated, the Digital Services Act, and also municipalities like New York City in particular. People were debating things like the anti-bias audit law. There was also another sort of piece of legislation around AI transparency. So you were sort of starting to see going from very, very high level principles to sort of more legislative proposals. And one of the kind of things that became really clear very quickly was that one of the big bottlenecks was not necessarily legislative design, but was going to be enforcement. And so let me explain what I mean by this. So when we talk about when an AI system fails, I think sometimes people like to talk about it like it's a misbehaving toddler. So an example is, early versions of ChatGPT was not very nice to minorities. And then, the formal statements from like some of the engineers involved were like kind of treating it the way that you would treat a toddler when they came back, saying a bad word that you didn't know about. And you were sort of like, I did not teach that kid that, I don't know where they learned that or where they heard that. That was sort of how the OpenAI research engineers were sort of reacting to ChatGPT's misbehavior. And I think sometimes when we interact with AI systems, there's sort of a tendency to look at things through that perspective of sort of anthropomorphizing these systems and treating it like a misbehaving child. But in reality, especially as things started translating towards a legislative path that required enforcement, it was very clear that, actually, a lot of these systems are products like any other type of product. So an AI system is effectively more like a toaster than it is a toddler. And so what does that mean? Well, actually, there's a lot of exciting things. It's like, because of a lot of advocacy in the 60s with Ralph Nader, the turn of the century with pharmaceuticals and food safety, the US actually has pretty decent, some people would disagree with what I'm saying completely, but we have pretty decent product safety laws. So we have quite a few legislative arms to sort of control and think about, regulating toasters. And so, one interesting opportunity for computer scientists to sort of contribute or to think about this is, well, if you take, an expectation that we would have of any other type of product, let's say false advertising and fraud expectations around something like a toaster, how do we translate that into AI? And so that was exactly what happened with the FTC in September 2024. Looking at their responsibilities around false advertising and fraud, they started kind of applying that or thinking about that as it related to AI claims. And the interesting thing is that, even before our sort of decade of AI policy timeline begins, they've actually pulled a bunch of, people don't really pay attention to this as much, but this has been a pretty effective strategy. We call these sort of UDAP laws. There's a couple folks that have started really writing some great stuff about this. Talia Gillis at Columbia has written a great article now. But people are realizing that, a lot of the effective sort of AI policy kind of enforcement we've had has been through these UDAP laws with the FTC. So for example, they took down a melanoma app that wasn't working very well on darker skin, and it wasn't because of any kind of anti-discrimination or civil rights claim. It was because the company was making false claims around how well it would work for different skin types, and so it's just false advertising. They removed it off the market. So, interesting to think about sort of how existing legislative frameworks might apply to AI. But I think more recently, something that's been exciting to me has also been thinking about how we actually have quite a few organizational level, legislative frameworks or policy frameworks around product safety, making sure that the kind of products that we introduce into organizational environments work well towards the goals of that organization and keep everyone safe within that organization. And so we might actually adopt some of those tools and think about how that might change with AI. So an example is I've been very kind of engaged in conversation for quite a while about procurement compliance. I know Suresh is passionate about this. Deidre Mulligan has been doing quite a bit about it. But working with folks like GovAI and the Health AI Partnership and NIST to think about, if we're going to adopt AI into organizational settings, how do we set up standards and procedures to do that well and safely? Another example of this that people don't always think about is distributor requirements. So if you think about AI in healthcare, a lot of the way AI enters the healthcare space is through platforms. And so in the case of hospitals, they'll actually adopt AI through integration with a platform like Epic. That platform is actually regulated. In the US, it's regulated through ONC, which is an IT healthcare regulator. And ONC might not necessarily be able to control exactly what the AI model vendors are doing. The FDA might be in charge of that. The model vendors might be escaping through regulatory arbitrage, the classification of AI. And so it might be really tough to control what the vendors are doing. But if you control and you kind of set rules around what that distributor platform is doing, in this case, Epic cannot introduce models that do not meet a certain documentation standard, that do not meet a certain third-party audit standard, then you can actually kind of introduce a new set of regulatory rules. So just, again, adopting some of these strategies that we've thought about for regular sort of toaster, and this is sort of like a similar strategy to how you would think about, the distributor of a toaster at a Walmart, right? So it's just like the kind of thinking about the frameworks that we use for any other type of product and trying to think about how that might apply for AI products. Just in terms of next steps for this bucket, something that I find interesting as sort of a next step for this has been being very concrete in kind of specific technical terms around what legal compatibility means. So if we want to enter a world in which we can actually enforce the laws that we're setting about AI, how does that affect our technical definitions for certain things? As an example, in the kind of machine learning fairness space, we have a technical definition for the notion of disparate impact. We have technical definitions, debated technical definitions about the notion of disparate treatment. But then we now are seeing these cases play out where sometimes the technical definition works. So FTC, for example, led this investigation into Rite Aid facial recognition. They used some of these definitions and it worked very well. But sometimes the technical definitions do not work. So there's a couple examples of these very serious failures where the technical definitions were thrown out by the judge or misinterpreted completely. And so what's the mismatch between sort of practice and theory is kind of an interesting next step for that bucket of compatibility or kind of practical coordination. So very quickly, I promise it will take less time. There's sort of also these other buckets of opportunities for how we could potentially impact or shape AI policy more meaningfully as a computer science community. But effectively with the practical coordination, something that I'm noticing is that we used to go 10 years ago from these high-level proposals, and now a lot of the utility of computer science has been informing enforcement, thinking about how we can actually, by our knowledge of our kind of the nitty-gritty of the technology itself and the nitty-gritty of what these methods require, we can actually inform the way that we can apply these laws, existing laws and laws that are kind of new in the AI space. So next, let me talk about this idea of technical infrastructure. I also want to be mindful of time. I started late. I don't know if I should end late. Okay. I can spend 15 or 20 more minutes, maybe. I don't know how much time. Oh, 10? Okay. I'll be quick. So effectively, audits are these evaluations with the goal of accountability. One of my first experiences in computer science was this gender shades audit, where we took commercially available facial recognition products. We evaluated it on kind of a diverse data set. And we found that a lot of these technologies in production kind of underperformed for this darker female demographic subgroup. And the goal was not necessarily just, the typical kind of machine learning model ranking, but it was to inform, federal, state, municipal legislation, procurement practice, et cetera. Oops. And so, one kind of interesting opportunity for kind of a technical contribution for AI policy is this idea of building technical infrastructure to support certain processes like AI auditing. So, resourcing AI auditing is a huge topic. This idea of what are the resources and tools that we actually need to enable people that are doing this work, that are thinking about constructing these evaluations with the goal of feeding them into these legislative accountability processes. This looks like a very scary chart, so I'll walk through it very quickly. There's some of these tools that are very oriented around this idea of harms discovery, so pretty much identifying a harm, identifying who's been hurt. Some of the tools are very focused on the evaluation process itself, so defining standards and performing kind of an analysis of the output of the system. And then some of these tools are very focused on sort of the postscript of evaluation, which is how do we make sure that these evaluations actually feed into meaningful processes of accountability. And so a lot of the work I did with Mozilla was this open source audit tooling project where effectively we funded about 14 different audit tools across this entire spectrum. We also informed a lot of legislation looking into resourcing the development of these tools and kind of pushing forward the development of what we call AI accountability infrastructure. And a lot of that work was led by Victor, who was incredible. But effectively what we were doing was trying to say, people that are doing this audit work have a lot of needs, technical needs, and the computer science community can build a lot of these tools. So I don't want to get too much into the details of this, but effectively, there's a lot that we've learned from building the tools in terms of the shift in the perspective on how these tools will get built. Let me see if I can go through it in 3 minutes. But effectively, if we were to take that taxonomy of different tools, the tools kind of play 3 different roles. There's the sort of harms discovery tools that are meant to just sort of set an alert when something has gone wrong. There's sort of the performance analysis tools, which are meant to do the assessment and the evaluation. And then there's sort of the postscript tools that are meant to sort of facilitate the accountability process. The main takeaway here was that, we were seeing, about 10 years ago, what we would be seeing was a lot of the tools were very focused around, single systems, single actors, being pretty ad hoc. But we realized that there's actually a lot of potential for different types of tools that could address a more holistic set of needs, especially when we're thinking about AI accountability, not in an abstract sense anymore, but as it related to complex real-world deployments. I'm being very ambitious, but I'll try to talk about this in the next 2 or 3 minutes. But a couple examples that I was going to share was, a lot of the work we were doing around AI harm taxonomy or sort of raising the alarm when something goes wrong. Historically, the way that we would do that is in a very ad hoc way. You get a tip from someone that's been from a harmed population. And then you build a taxonomy of all the ways that things could go wrong. You look at historical accident catalogs, that sort of thing. And so kind of the new approach, or something that we would embrace with the tooling, would be this idea of an AI incident database. So at a high level, an AI incident database is an opportunity to collect individual reports of experiencing a harm related to a particular AI system, systematically sort of aggregate those reports and analyze those reports, identify patterns in those reports, and then raise an alarm to kind of spur further investigation or an AI intervention. And this is work that we're now starting to do with the UK AI Safety Institute and UCSF. Another example is sort of the way that these tools have shaped our approach to evaluation. So, historically, the way that you would evaluate an AI system and how well it's working is you would send a lot of inputs into the system. You would see what would come out of that system, and then you would see whether that output sort of matched your expectations for that system. And so this is benchmarking, as many people in computer science are aware of. There's a lot of issues with benchmarking. The community has been talking a lot about benchmarking for many years. But something that's come up in kind of practical audit settings is that, the concern in a lot of accountability-related scenarios is not necessarily that the outputs of the particular AI system match or don't match our pre-articulated expectations, but that, really what you're not dealing with is just an AI system in isolation. You're dealing with an AI system in conjunction with an individual human user, and that individual human user in many cases is affecting an impacted population member. And so what you need is something that can help us evaluate this entire spectrum. And more importantly, very rarely do you have an individual user operating with full discretion. The individual user is sort of operating under the framework of, historical norms, developed through their training or organizational level guidance. And so what we really need to evaluate is not just that individual user's actions in the deployment scenario and this human AI system, but how that human AI system might shift under specific organizational and normative settings. And so, going beyond benchmarking ended up being a huge theme of a lot of the tools, and facilitating evaluation beyond benchmarking became a huge tool to sort of shift from a model-centric view to something oriented towards a more ecosystem view. So as an example, this is a project we're starting with Stanford Hospital. Usually you have an AI system deployment. This is a simple risk assessment that's deployed within the hospital setting. And then you have sort of organizational level outcomes. And typically you're maybe evaluating just sort of the inputs and the outputs of that system. And it's very disconnected from understanding the effect on these organizational level outcomes. And often, a lot of computer scientists will treat these organizational implementation choices as vague or abstract. When in reality, in very structured public interest settings like government and medical settings, there's actually a pretty clearly defined relationship between the outputs of the model and the outputs at the organizational level. And so, one interesting direction tool-wise has been like, okay, well, how do we think about, simulating that organizational workflow level kind of outputs? How do we think about things through this lens to get sort of more meaningful evaluations for accountability? And then finally, because I'm unfortunately really running out of time, there's been sort of an interesting shift in the tooling landscape around ACT, or sort of feeding the evaluation outcomes into meaningful processes of accountability. Things like documentation have obviously been a very critical tool in documentation templates. So first we've had model level templates like model cards. That was developed in 2019, very focused on getting engineers to write everything that they know and decisions that they made about the model. And we want to shift that towards what we call the SMACTR framework, where actually there's a lot of different choices being made about the model. And there's sort of history from other domains, aerospace, medical settings, finance, where they have this sort of internal audit practice where they document all kinds of decisions that are made throughout the model development process by different types of stakeholders. And so, can we develop a more holistic end-to-end process for this internal audit, documentation-based internal audit practice? And so the SMACTR framework is kind of like expanding towards a more systematic view, and this has been adopted in healthcare settings. Again, it's been cited by ONC and NHS, but also very much adopted in government settings as well. So NIST and GAO, which is the Government Accountability Office, have cited this in their the kind of internal AI development practices within government. But the sort of high-level takeaway here is that when we start thinking about AI accountability for complex real-world deployment, rather than in this abstract sense, we sort of shifted from just focusing on the model and sort of this ad hoc approach towards tools that allow us for sort of a more complex, grounded approach. And so, we're kind of moving from this ad hoc, myopic tooling ecosystem towards something more systematic and centralized. And this is like a 2-second slide thing, so I'll say it very quickly. The sort of last thing I think computer scientists could be useful for is this idea of institutional design. And obviously I will talk about that in the context of audits, because that's what I work on. But effectively, audits are a huge part of product safety for a toaster. And the difference between the AI audit space and the toaster audit space is that they have all of these policies and laws that guide the effectiveness and enable audits to happen in their particular industry. So an example is auditor access and privileges. They have opportunities to go in and get the information that they need to do an effective evaluation and feed that into a meaningful process of accountability. In the AI space, we're just beginning to see that. 2 recent examples with platform-based AI systems is the Digital Services Act and the Online Safety Bill. But some interesting dimension of this is that it requires a lot of institutional design and building. So, Ofcom and ICO are two organizations, regulatory organizations in the UK that are very involved in enabling the online safety bill to even happen. And the European Commission has put out, various offices to sort of mediate the development of the DSA because, accrediting auditors, giving them access, building the technical infrastructure has to be housed somewhere. And so this institutional design is actually a very critical point. I'll say one last thing, which is the next steps for this is a lot of the AI safety institutes and a lot of these practitioner networks are kind of playing this role domestically, and I find that pretty interesting. So the kind of key point around the institutional design is that we've gone from very reactive tools and reactive frameworks to something more proactive. We're kind of, rather than just responding to the need for organizations to step in, we're proactively designing organizations like the AI Safety Institutes to address kind of new institutional design needs. The kind of main takeaway that I wanted to bring was that, over the last 10 years, my theory of sort of what's been effective has been folks that embrace a more grounded approach to AI policy. Before, things were very high level, the technology was not very concrete, and so we were stuck with thinking about things through this lens of proposals and sort of ad hoc, reactive framework. And in the last 10 years, as we've seen more and more of these AI products make their way out into the world, we can kind of shift towards thinking about enforcement, thinking about more systematic or centralized infrastructure approaches, but also being more proactive about what to expect next. I was going to give an example, and I might as well end on this. One example of this that I think about quite a bit, and I shared in my class, and I'm sure I'm triggering anyone that took our class, because we talked about this example quite a bit, is this idea of criminal pretrial risk assessments. So in November 2020, there was Prop 25 was a vote for pretrial risk assessments or cash bail in California. And people would either sort of be released automatically based off of their assessed risk or commit cash bail. And so a yes vote would mean sort of no pretrial risk assessment, and a no vote would mean yes to cash bail, and yes to pretrial risk assessments and no to cash bail, and then yes would mean end cash bail but give them a risk assessment. And I think CS Research really contributed to the way that this vote played out. ProPublica, has a very famous investigation into the bias of these risk assessments that really shaped a lot of the public opinion, but also a lot of the discourse at conferences like FACT. And I think that really informed, I know that really informed because it was cited in a lot of the letters from like ACLU Northern California and other civil society groups that endorsed the no vote, so no to risk assessments, because they had seen sort of ProPublica and some of the FACT research on this topic. And so in California, they voted no. But a decade before that, in 2015, or actually November 2014, which is even earlier, before ProPublica's article, which came out in 2016, 60% of New Jersey voters actually made the opposite decision. So they voted to end cash bail and to approve these risk assessments. And this is sort of before public consciousness on bias in criminal risk assessments. And so, part of it is because risk assessments were seen as the more fair choice prior to this research. And so, what New Jersey sort of presents as an alternative hypothesis of, what would happen if we hadn't done that research and hadn't shaped that opinion, or we had been more careful or taken a different approach to our research. And we now have some data on that, which is effectively that there's a lower jail population, but a lot of the bias has gotten worse. And so it's a very nuanced take, but it's a very interesting alternative hypothesis to the role that computer science plays in some of these real-world policy-making decisions. I'll say one last thing, which is effectively, now we're in a world in which people do take that more grounded approach. And so we have ProPublica's result, but now we have sort of papers like Albright's result that reveal some of that finding that risk assessments make judges more lenient, but more lenient towards white defendants versus black defendants. And then now we even have like experimental evaluations of these risk assessments that reveal that there's not much of an effect. And so this is something that like me and some colleagues have been thinking a lot about, is like how do we actually integrate and think about things through this more reflective and grounded approach. Yeah, I'll end there. I'm so sorry, but thank you. Yeah, so effectively, one of the main takeaways here is that, as we shift towards these products that are affecting more and more lives, we should take more responsibility, our role in shaping the public policy conversation as computer scientists. Yeah, I'll end there. Sorry. I don't know if I should keep this up or that's fine.
Thank you, Deb. That
Yeah.
was an amazing overview. So we really appreciate that.
Yeah.
Our next speaker is Manon Ravel. And Manon is a senior research scientist at Google DeepMind. She builds mathematical and computational